A note of the problem of the 8 queens by W. H. Bussey, University of Minnesota. This is recorded to celebrate the 8th anniversary of LibriVox. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Finite geometries were defined by Veblen and Bussey in the Transactions of the American Mathematical Society, Volume 7, 1906, pages 241 to 259. References to existing literature of the subject were given in this monthly, 1921, pages 85 to 86. The simplest case of a finite plane geometry based upon an odd prime, the Euclidean plane geometry, modulo 3, was presented in detail by Bennett in this monthly, 1920, pages 357 to 361. The problem of the 8 queens is the determination of the number of ways in which 8 queens can be placed on a chess board, or more generally in which n queens can be placed on a square board of n squared cells so that no queen can take any other. It was proposed originally by Franz Nock. The object of this note is to show that in the special case in which n is a prime number p, there is a connection between the problem of the queens and the lines of the finite plane geometry of p points to the line. The cells of the chess board are represented by their middle points, which constitute a finite Euclidean plane geometry of p points to the line. In order that one queen may take another, the 2 queens must occupy cells whose representative points are on a vertical line, on a horizontal line, on a line of slope 1, or on a line of slope p-1. The slope p-1 is the same as the slope -1, since p-1 is congruent to -1 modulo p. Therefore, if p queens be placed on the cells whose representatives are the points of a line whose slope is any one of the integers 2, 3, 4, and so forth up to p-2, no queen can take any other queen. The total number of such lines, each of which furnishes a solution of the problem of the p queens, is p squared plus p minus 4p, or p squared minus 3p. When p equals 5, the number of solutions obtained by this method is 10, which happens to be all the solutions that exist. When p equals 7, the number of solutions furnished by this finite geometry method is 28, but, as a matter of fact, there are 40 solutions when p equals 7. For higher values of p, the lines of the finite geometry furnish some, but not all, of the solutions of the problem. End of a note on the problem of the 8 queens by W. H. Bussey.